So the first one, when you graphed it on Desmos, it showed you this. Well, most of you probably already knew this was your parabola. Y equals x squared was one of the functions you studied in Algebra 1. So when we look at this, I'll cover up that real quick. When we look at this, how do we know this has a degree of 2? To find the degree of a function when it's in standard form, we go to the term with the highest degree. Well, this only has one term, and the degree of this term is 2. So the degree of this polynomial is 2. So the degree is even. Now, hopefully as you went through the packet, you noticed a difference when we had an even degree function and when we had an odd degree function. When the degree of the function was even, the end behavior is the same, whether both ends go up or both ends go down. When the degree of the function is even, both ends do the same thing. So on this one, both ends were increasing. So as x approaches negative infinity, so as we go this way, what's happening to the function? The function approaches positive infinity. As x approaches positive infinity, the function approaches positive infinity. Now, this is the parent graph of the parabola, so the x-intercept and y-intercept are both at the origin. So my x-intercept is 0, 0. Now, this was my equation, but they said, hey, could we write x squared as x minus 0 squared? And after you saw a couple of these, this form where we do x minus something, the a ends up being your x-intercepts. So if this were negative 2, your x-intercept would have been positive 2. If this was positive 3, your x-intercept would be negative 3. Basically, it's what can we plug in here that makes this factor equal 0. Because when the factor equals 0, when we plug it in, our y is 0. And that's what the y value is anywhere on the x-axis. The y value is 0. So this has an x-intercept at 0, 0. Now, the other thing they wanted you to notice, as you did lots of different types, was when the factor is raised to an even power, at that 0, at the x-intercept right here, the function is tangent. It touches and bounces back. It does not pass through. So when we have a factor raised to an even power, we've got this point of tangency right here at the x-intercept. So this graph is tangent to the x-axis. It touches and bounces back. And on this one, the y-intercept is 0, 0. Any questions about the first one? Well, the second one, all it did was take that first one and it flipped down, didn't it? It is just like the first one except for the negative out in front. The degree of the function is still 2. So it's still an even function. So the ends have to do the same thing. It's either rise, rise, or fall, fall. And in this case, this negative out in front, when we have a negative leading coefficient and an even degree, our ends of the function fall. It falls to the left and it falls to the right. So if we were to write this using the correct notation, as x approaches negative infinity, so as x goes left forever, the y values approach negative infinity. The function goes down. As x approaches positive infinity, y also approaches negative infinity on this side. It falls to the left, it falls to the right. So, when we have an even degree function with a negative leading coefficient, the ends fall, fall. Now, that's really the only thing that changed. It reflected it over the x-axis. The x-intercept is the same. It is still tangent because this factor, just the factor part, is still squared. So it's going to hit and bounce back at 0. Okay, so when you were comparing, they're both parabolas. One opens up, one opens down. They're reflections of each other. The end behavior on the first one, both ends did the same thing. The ends of this one, both ends do the same thing. But on the first one, they went up, and on the second one, they went down. So if we have an even degree, the ends are going to do the same. If the leading coefficient is positive, those ends go up. If the leading coefficient is negative, those ends go down. Now the next one was not even. This one has a 3. So this is an odd degree. This function has an odd degree. And when they're odd, the ends do the opposites. So one goes up, the other goes down. So it either looks like this or it looks like this. So if the degree of the function is odd, the ends do opposites. So if it's a positive leading coefficient like it is on C, and an odd degree, it's going to fall to the left and rise to the right. Now, the other thing you should have noticed is the x-intercept is here at 0, 0. It passes right on through here. It does not bounce, does it? It passes through. But it passes through in an interesting way. If we look at this left side, do you see how this is kind of concave down? Concave down right here. But this side is concave up. It's almost like there's a little squiggle right there at the origin. The curvature of the graph changes. It changes from concave down on the left side to concave up on the right side. So that makes the origin, this x-intercept of the graph, an inflection point. So not only does it pass through here, where it passes through, because this factor is raised to an odd degree, it's going to pass through. But if the odd degree happens to be greater than 1, like 3 or 5 or 7, an odd degree, if the factor is raised to an odd power higher than 1, it doesn't just pass through. Where it passes through, it changes concavity. It passes through with an inflection. Y'all see how it curves there? It's not a straight line. It doesn't go straight through. It changes curvature right there at that inflection point. Okay, so that was one thing they wanted you to note. When we have a factor raised to an odd degree, it's going to pass through. But if that odd degree is greater than 1, it passes through with an inflection. Okay, so yes, it continues through the x-axis with an inflection. Okay, so if you didn't write with inflection on your passes through, let's go ahead and write that in there. The curvature of the graph changes. It goes from concave down to concave up. And we want to make a note of that. Okay, so let's keep going. All right, so this one's just like the last one, except there's a negative out in front. So the function has an odd degree. It's an odd degree function, so the ends do opposites. But this time, because we have a negative leading coefficient, it's going to rise to the left and fall to the right. Do you see how it's going up over here and down over here? Now, this one changes curvature. Do y'all see that? It goes from concave up to concave down. This is an inflection point. Why is it? This factor is raised to an odd power greater than 1. Okay? So this one, as x approaches negative infinity, y approaches positive infinity. So as we go left, the y's increase. As we go right, the y's decrease. Now, so far, everything we've done has only had x-intercepts at 0, 0. But so far, every time we got the equation, we could write it as x minus 0 to a power. Let's go back and look. X minus 0 to a power, x minus 0 to a power, x minus 0 to a power. So the next one takes it a little further. We still have x minus 0, which really could just be x. But then we have x plus 2 and x minus 1. So let's investigate what changes that caused in our graph. All right, when we look at this, these always give us our x-intercepts. And they're the values that make this factor equal 0. Well, x minus 0, what can I plug in here to keep this 0? 0. X plus 2, what can I plug in here to make this 0? Negative 2. What can I plug in here to make this factor 0? Positive 1. Okay? Now, if you can't just look at it and do it, that's fine. Take one of them, set it equal to 0, and solve. What do we do to solve this? Just subtract 2. So we know that there is an x-intercept at negative 2. There's an x-intercept at positive 1. There's an x-intercept at 0. When you looked at the Desmos graph and you looked at the equation, did you kind of see that happening over and over and over again? Now, each one of these factors is raised to the first power. Did you notice it passes through, passes through, passes through? But this time there's no inflection. It is an odd power, so it's not going to bounce, but it's only 1, so it goes straight through. There's no inflection. Now, if you had to graph this without a calculator, how would you know that this end goes down and this end goes up? We'd look at a couple things. The first one is the degree of the function. This is 1, this is 1, this is 1. And all these x's raised to the first power are being multiplied. When we multiply like bases, we add the exponents. 1 plus 1 plus 1 is 3. So if you're given a list of factors, that's how you find the degree of the function. You have to add up those exponents. Okay, so we have a third degree function, so the function is an odd degree, and we have a positive leading coefficient. When it's a positive leading coefficient and an odd degree, it falls to the left and it rises to the right. And then we know it passes through each one of those factors. So pass through, loop around, pass through, loop around, pass through. That's how we could graph it without a calculator. So this one has more x-intercepts than the others. That's how it's different. How it's similar, it still has the same 0, 0 as one of our x-intercepts. And this one continues through like our other third power one. There's no bouncing back. There's no bouncing back because each of the factors is raised to an odd power. Okay, let's take a look at this one. This one is just a reflection of this one. Because of this negative, that is the only thing that changes. And a negative leading coefficient, when we have an odd degree function, makes it rise to the left and fall to the right. And then at each one of these intercepts, because they're all, these factors are just to the first power, passes straight through, passes straight through, passes straight through. Okay, questions about it? All right, let's keep going. All right, so this is where to start mixing it all up. How do we know this is a 4th degree polynomial? Well, it's written as a product of factors, so we add the exponents. 2 plus 1 plus 1 is 4. This is even. Well, we know when we have an even degree function, the ends do the same thing. They either rise, rise, or fall, fall. Because this is a positive, it's positive, leading coefficient, it's going to rise to the left and rise to the right. I know there's an x-intercept at 0. There's another one where? -2, and another one at +1. So -2, 0, +1. Okay, so now I'm going to start right here. At the -2, it's to the first power, passes through. 0 is my next one. 0 is to an even power, so it's going to bounce. It is tangent there. If a factor is raised to an even power, your graph bounces at that point. It is tangent. And then at 1, it's just to the first power, so it passes through. All right, so this one was tangent at x equals 0, and it passed through at x equals -2 and +1. All right, this one. We still have the same x-intercepts. 0, -2, +1. So -2, 0, +1. But the degree of this function, this is an understood what? 1. So 1 plus 2 plus 2 is 5. It's odd degree with a negative leading coefficient. So when it's odd and negative, it rises to the left and falls to the right. At -2, it's an even powered factor. Bounce. At 0, it's an odd. It's going to pass through with just a straight line because it's an odd first. At +1, at x equals 1, it's an even factor. Bounce. Okay? So this is tangent here at 2 and at 1, -2 and at 1. X equals -2 and x equals 1, it's tangent. It's bouncing there. And it passed through at 0. Okay. Last one we're going to go over together. Yes?
I have a question. How did you get the y-intercept?
The y-intercept is supposed to be 0, 0 for all of these. Sorry. The answer key was a little messed up. The y-intercept for every single one we've done is 0, 0. Okay. All right, so H I. Okay, so you didn't need this part because we did it on Desmos instead of the calculators. We could have done the same activity on the calculators, but we chose Desmos. Desmos is just easier. So we have an x-intercept here at 0, 0, -2, 0, and 1, 0. Same x-intercepts. These factors give us our x-intercepts. Now we look at the degree. 2, 4, 6, even. And negative leading coefficient. So if it's an even degree function and a negative leading coefficient, it's going to fall to the left and fall to the right. Now each one of these factors is squared, so it's going to bounce, bounce, bounce. It is tangent at all 3 of those x-intercepts. Nope, it'll do one or the other. So it'll either pass through the x-axis or it will be tangent. It will hit and bounce back. So now I'd like you to try, that is not us. I would like you to try K. No, J. J. All right, no calculators, no computers. I want you to use what we've talked about to try to graph this equation here. Use what you know about end behavior, use what you know about root behavior. Does it bounce? Does it pass?
We're going to need these for
J. Okay, let's start with our x-intercepts. What x-intercept goes with that factor? 0. What x-intercept goes with this factor? -2. What x-intercept goes with this factor? 1. Okay, what is the degree of the function? 5. So it is an odd degree function. Is the leading coefficient positive or negative? Positive. So if it's odd and positive, it falls to the left and it rises to the right. Okay, so that's where I go next. So first, plot your x-intercepts. Second, do your end behavior. Third, look at your root behavior at those x-intercepts, at the roots of the equation. Does it bounce, meaning is it tangent, or does it pass through? So at -2, this factor is raised to the second power. So what does it do here? Bounce. Okay? 0. This factor is raised to the second power. What does it do? Bounce. At 1, this factor is raised to an understood first power. It's just going to pass straight through. No inflection. Because it's an odd power of 1. Pass straight through, no inflection.
So if it is raised by one power, it just goes
Straight through. Okay? Now, this summarizes what I've said over and over and over and over again with every single problem. This is what we're looking for when we try to graph without a calculator. And this is what I'm going to ask you to do as you finish this packet tonight. Okay? These notes will be posted. If for some reason you don't finish summarizing, it'll be posted. You can look at it online. And then your homework is to finish the packet without using Desmos, without using a graphing calculator. Okay?